right, here we go. I'm proud of you for trying your best on this one. People enter a line for an escalator, and there's the rate. This is a rate question. And so likely one of the questions is going to say, how many people enter the line? That's integrating. Or it's going to ask, is the rate increasing or decreasing? That's taking the derivative of it. So see what you see the pattern that repeats over and over. So what are they going to ask? There you go. How many people enter the line? So what am I going to do? I'm integrating. So from 0 to 300, I'm going to integrate this. So wait, I'm going to put this in the calculator. I'm not going to put in the 0, just the top one. All right, so I'm going to change F1 to that. So it's going to be 44 parentheses x over 100. That's not 100. To the exponent 3 parentheses 1 subtract control divide x over 300, and then to the exponent 7. Double check. Does that look good? Answer. That's F1. And now I'm going to start reading. So how many means I'm going to integrate. I'm going to integrate from 0 to 300. I'm going to integrate that, and then that's it. I'm going to type it in my calculator. Easy. How many? Such an easy question. So menu, calculus, integrate from 0 to 300. Oops, that's not 300. And then it's F1. All right, what do we got? 270 people. All right, part B. During the interval from 0 to 300, there are always people in line for the escalator. How many people are in line at time t equals 300? So people enter here. So how many people are there in line at t equals 0? 20. From 0 to 300, how many people enter in? And then what else happens? Oh, they exit the line at a constant rate of 0.7 persons per second. So we started with 20 people, what it says, right? And we have 270, and they exit at that rate, 0.7. And then use your calculator. Oh, wait a second. Here, let's do it again. So we have 20 people. We have 270 that entered in. And then at t equals 300, there's always that many people, right? They exit the line at a constant rate of. So that means I subtract. They're exiting at that rate. All right, be a reader. I can do it. So 20 people. We just found 270, right? From 0 to 300. And then we subtract the ones exiting. So it's 300 times 0.7. And that leaves me with 80 people in line. See, when t is greater than 0, there's the rate. What is the first time t that there are no people in line? Now the rate is 0, which means it's still constant. So at 300 seconds, we have 200 and we have 80 people wait in line. And at what time, I'm thinking through this, is there no people in line for the elevator? So the rate is 0. How long until that many people exit? So we have 80 people that are waiting. I'm not sure. Let me look at this. Look at something real quick. All right, let me look at this real quick, because I don't want to give you the wrong answer. What year is this? Because I'm feeling a little confused. See, I can get confused. It's all good. I bet once I see it, it'll make so much more sense to me. So the time, so 300, at 300 seconds, there's still 80 people in line. And then how quickly do they, you would divide by 0.7 instead of multiply, and then it would give you the answer 414.286. That's how long it would take for those 80 people to go. I know, that was confusing. Part D. From 0 to 300, what time is the total number, is the number of people in line a minimum to the nearest thing? So we take it, we need to find the derivative equal to 0. And we need to find our critical numbers and draw a number line, right? So how to know how many people are in there? So to know how many people are in line, we go 20 plus 0. So that tells me how many people are in line. Then you subtract the ones that are leaving, right? And then you make that equal to, take the derivative of that. So the derivative of that, the derivative of 20 is 0. The derivative in this, they cross out, just plug in t. And the derivative of this is just 0.7, and make it equal to 0. So it's just r at t equaling 0.7, and then solve that equation. So I'm going to go menu algebra solve, and it's f1 at x equals 0.7 comma x, oops, and I get 33 and 166. So 33 for 166. And then we're going to do a table of values with those numbers. So we have 0 and 300. We have 33.013. 166.574. And then you're going to plug it into this to see what your answer is. So if I plug in 0, 0 to 0, that's 0. 0.7 times 0. So all you have to say, at the beginning we have 20 people. Then if I plug in 300, just so you know what it would look like on the calculator, and then once it's typed in, we don't have to keep typing it in. So it's 20 plus menu calculus integral from 0 to 300. But we already did 300, right? That was the question before. We got 80, right? So I don't need to do that. So, but I do need to do the next one, which is 33.013 f1 at x dx. And then we're going to subtract 0.7 times t, which is 33.013, and I get 3.803 people. So that looks right in terms of a minimum. That looks pretty good. And then I do the same work, but for 166. Change it. And I get 158. All right, so the question again is, where's the minimum? At what time is there a minimum? And you can see right here. So at t equals 33.013 seconds, there is a minimum of 3.803 people waiting in a line. Right, I'm done. All right, thank you for not giving up. Thank you for being patient when I didn't know what the right direction to go is. And be patient if you still don't understand it. Like, what do you understand? Can you do half of it right and try to keep doing more the best you can, all right? I believe in you. Mr. G Math over and out. Till next time.